In chapter 2 of this book, we're going to be discussing input gain. What is input gain? Why is it so important? Input gain is the structure, the building block of our sound. If we get this signal too hot, typically it's going to distort, which you do not want in the digital world now especially. And if the signal's too low, we're going to run into noise problems, more commonly referred to as your signal-to-noise ratio. The main reasons for trying to achieve this, what is termed as unity gain, is to just keep your levels even throughout the entire system. When a fader is set at 0 dB, it's neither boosting or cutting, it is at a 1-to-1 ratio. So what's coming in is exactly what's coming out. There is no op-amp or anything adding any coloration or noise or distortion or anything we don't want in our signal chain. The easiest way I've personally been able to understand the whole unity gain concept is when you parallel it to plumbing. In plumbing, you have pipes coming in your house with set water pressures. If that pressure is way too high coming in, this is akin to turning your gain on your input way too high. The eventual outcome would be your pipes bursting or valves bursting down the line, which would be akin to the distortion. The opposite is true. If the pressure is way too low, you're not going to have a very enjoyable shower. Now let's show you some real-world examples of both of these scenarios on the console. So we're here on the console. I'm going to send some pink noise into an input here. I'm going to adjust the gain on that input till we are at 0 dB unity gain, as we just discussed. My fader is also at 0 now. The output fader is at 0. Right now that signal is running from beginning to end at perfect unity gain. Let's throw a wrench in that though. I'm going to crank this gain way up. As you see, our input now is clipping like mad. Our output now is clipping like mad. And anywhere we send that signal will be clipping. We don't want this distortion in our signal chain, obviously. So by properly setting this back to unity at 0, you can see our output's back to 0. Every part of the chain will be back to 0, sitting at unity gain. Not making noise, not making distortion, giving us what we want, nice clean sound at the end. So we've got our input gain set to minus 30 dB. Our input fader is still at 0. Our output fader is still at 0. As you can see on the output meter, the output of the console is minus 30 because both these faders are at 0, which is a 1-to-1 ratio. What comes in is the level coming out. Obviously, this isn't going to be enough signal to drive into our amps to get enough sound pressure into the room. So we have a couple of options. They're not great options, but if it's the only option you have, you could do this. You could push the main fader up 12 dB, which gives you 12 dB more. You can push the input fader up another 12 dB, which gives you 24. So theoretically, you're only sitting at a 6 dB deficit. The problem is, we've introduced 24 dB of nothing but noise into the signal chain. So one final consideration in setting input gain is with digital consoles. Digital consoles, being a different beast than analog, have digital analog converters on their inputs, referred to in the industry as DACs. These DACs run on a different scale than analog, which is called dBFS. 0 dBFS is the absolute maximum that the digital analog can take. The problem is some manufacturers have an offset on their dBFS scale that run anywhere from -6 to -18. What this means is if you set your input gain to 0 on the meter, you're actually setting it to +18, which is going to just give you a ton of distortion and be very, very nasty sounding. So that pretty much sums up input gain and your settings. In the next chapter, we're going to have a look at output gain. Thank you for watching.